Read this, pause the video, and see if you can fill in that blank and put what goes there. And I will do it now. To measure voltage, you use guess what? Well, of course, a voltmeter. Just like you use an ammeter to measure current in amps, use a voltmeter to measure voltage in volts. And the symbol is also no surprise. Just as the symbol for an ammeter is a circle with an A, the symbol for a voltmeter is a circle with a V. And notice it has 2 points of connection that you put in the circuit. All right, for how to do this, it helps to remember what voltage actually means. This is an easy definition to lose track of, so you want to come back to it again and again until you feel you understand it. It's the gain or loss of energy by each charge between 2 points. So as charges move through the circuit, they gain or lose energy in different places. Between any 2 points, we can measure how much each 1 coulomb of charge gains or loses between those 2 points. So this idea of between 2 points is very important when you measure voltage. All right, here's an example, and I have a voltmeter here. This is actually a multimeter, but we'll set it to volts. So it acts like a voltmeter, and it's got 2 probes, so you can touch it to 2 places in the circuit. Black and red, as we've seen before, is a color code. Red should be at the higher voltage, black at the lower. If you get them backwards, it's not going to cause you any problems. It just means the reading on the voltmeter will be negative, but it'll still be correct. It'll just be negative. All right, and I'll show you how to use it. Here's what we've seen before, this idea of charges going through a circuit. They gain energy in the battery and lose it as they go through these circuit elements like the light bulb and the motor. You may want to pause the video and look at this and refresh your memory on what this means. All right, so to measure voltage, let's say we want to measure the voltage across this light. Remember, it's between 2 points. So we pick a point right before the charge enters the light and a point right after the charge leaves the light. We put the one probe there and the other here. And then the machine, the voltmeter, will tell us the voltage between those 2 points. We call that the voltage across the light. So see what we have to do? We don't have to break the circuit and put the voltmeter in the way we do with an ammeter, because we're not measuring something going through the light. Voltage does not go through things. Current goes through things. Voltage is the difference in energy between 2 points. So what we have to do is touch the voltmeter to those 2 points. And you'll notice I have here that the energy of this charge here is 6 joules for each 1 coulomb. And here it's 4 joules for each 1 coulomb. So if I put the voltmeter here, pause the video and predict what you think it would read. What it would read is the difference, the change in energy, not 6, not 4. It would read 2 volts here. 2 joules per every coulomb. All right, to measure the voltage across the motor, pause the video and think about what you would do. All right, I'll show you. We want to touch the voltmeter to a point just before the motor and just after the motor, and the voltmeter will tell us the change in energy per coulomb. Look at the numbers I've written and predict what you think that would be. Pause the video if you have to. All right, it would tell me 4 volts between these 2 places. You can also measure the voltage on a battery. Once again, you put the voltmeter probes on either side of the element. Here, the battery. So one here, and here it'll tell us how much energy each charge gains as it goes through the battery. So predict what you think the voltmeter would read in this case. All right, you should predict 6 volts. This is a 6-volt battery. Every 1 coulomb that goes through steals 6 joules of energy. It's like a gas station where everybody who goes through has to buy 6 gallons of gas. You're not allowed to buy less, and you're not allowed to buy more. So that's why we would read 6 volts here. All right. Here's a second example. You see I've arranged the lights a little differently. All right. And I'll just show you how to measure more quickly now, because you should be familiar with it. To measure the voltage on the battery, we do this. To measure the voltage on, or we say across light A or on light A, but not through it. Voltage does not go through. It's a difference in energy between 2 points. We do that. To measure the voltage across light B, I do that. Across light C like that. And I can measure the voltage across B and C together like that. All right, I want to draw something in here so we can talk about what a voltmeter must be like. Imagine I want to measure the voltage across light B. right? I would do this. Okay. Now think about what a voltmeter has to be like. Read the question here and think if you can fill in the blanks. You can pause the video if you want to work ahead. If a voltmeter were like an ammeter, like wire with very low resistance, what would this do to the light? It would short circuit the light. That's what it would do, and it would steal all of the current and the light would go off and the voltmeter would change the circuit. Or let's say we wanted to read the voltage across the battery. We would do that. All right, the voltmeter has to touch before here and after the battery, before the charges go in and after they leave, so it can measure the difference or the loss or gain, the gain of energy as the charges go through the battery. So look at what a voltmeter has to be like so it doesn't disturb the circuit. If a voltmeter were like wire, like an ammeter, like wire, with almost no resistance, what would it do to the battery here? You can pause if you want to answer that. It would short circuit the battery. Is that good or bad? It's very bad. It's going to create a very high current. This could create a lot of heat in here, could start a fire. It would burn out the voltmeter. The battery would lose its energy very, very quickly. So a voltmeter cannot be like wire. It cannot be like an ammeter. So what does it have to be like? Well, think about what was here before you put the voltmeter. There was nothing here. All right, so pause the video and try to answer the questions here. So a voltmeter must be like blank, and it must have blank. But what was here before? There was nothing. There was a gap. So a voltmeter must be like a gap, because that's what was there before you placed the volt. There was nothing here. There's empty space. And what kind of resistance does that have? Does charge flow really easily through empty space or with a lot of difficulty? Must have very high resistance. A perfect voltmeter would have infinite resistance, but a real voltmeter has very high resistance. And in our applications, when we do homework problems, we pretend that a voltmeter has infinite resistance. Because of this, you can't ever burn out the voltmeter or break it in any way electrically by connecting it up to the battery wrong. You'll just measure the wrong voltage. You won't ever short circuit anything with a voltmeter, and you won't ever burn anything out. Here I have a simple circuit set up. Two batteries are set up in series. We call that stacking the batteries. Then we also have two lights in series. The lights have different resistances, so they have different brightnesses. And in the video, it might be hard to tell, but both lights are on, and this light here is brighter. I'll show you how you would use a real voltmeter to measure real voltages in a circuit. Let's say we want the voltage on this light here. Well, we can conveniently use the screws. We put the probes on either side. We want to measure the energy before the charges enter the light and after they leave. And you may not be able to see it, but the voltmeter is saying 7.9 volts for that light. We say there's about 8 volts across that light. Let's do the same for this light. Okay, about 3.3 volts across that light. That means for every coulomb of charge going through this light, it loses 8 joules of energy, and every coulomb that goes through this light loses about 3.3 joules of energy. Right? I'll show you how to measure the voltage on the battery. You can use the metal terminals on the battery. So right like this. Okay? Get about 5.9 volts, which would what we'd expect for a 6-volt battery. And for this one, I get 5.7 volts. That battery's probably a little older. I can measure the total voltage that I get across both batteries. That gives me the total voltage, kind of the total pushing power for these two. And it's what you would expect, 11.4, 11.5 volts. I can also measure the total voltage loss across both lights by going like this. And it's what you would expect, about the same, 11.4 volts. So I had 11.5 here, 11.4 here. Why the small difference? Well, because wire really isn't free. There's a small loss of energy across the wire.